We are working in the second half of section 3.2, and we are focusing on word problems today. And so we're going to do these word problems for systems of equations, solving using substitution elimination, but we are also going to come back to word problems we do systems of inequalities and in linear programming in 3.4. So these word problems are not going to go away. It's also good practice for us to use substitution and elimination method. First thing you want to do in all of these word problems, you want to read through the entire problem and you want to pull your important information, and we want to focus on finding our variables and defining them correctly, because that really sets up how we build our equations. So we have a zookeeper who needs mix to feed prairie dogs, so the feed has the right amount of protein. So feed A has 12% protein and feed B has 5% protein. So we have a high protein and a low protein, so probably more expensive, a little cheaper. And we want to know how many pounds of each does he need to mix to get 100 pounds of feed that's 8%. So this is our end goal. We want a mix that's 100 pounds, 8%. And it says round the answer to the nearest tenth. All right, now I want to back up right here. How many pounds of each does he need? That's what's important. So X, we know that we have two types of feed. We know how much protein is in each feed. What I need to know is how many pounds of each. How many pounds of each? So there it is. X represents the amount or number of pounds. Amount of feed A, and that is measured in pounds. I'm also going to write that it's 12% protein, just to help me organize my thoughts. B is going to be the amount or number of pounds of feed B. And that again is measured in pounds. It's important we know what it's measured in. And this one's the lower, so 5% protein. Okay, now we need to write two equations, and we have more information than you might realize. The first equation is simply X plus Y equals 100. Okay, so where did I get that? We need to get 100 pounds of food. And if X is how many pounds of A and how many pounds of B, can you picture taking these two bags of food and pouring it into one big bucket? So if it helps you, sometimes we make these little drawings. So picture these two bins. All right, we're going to add these two bins together, and they're going to mix into one big bin. So this is feed A and that's feed B, and this one is X pounds and this one is Y pounds, and 12% is the description and 5% here. And so if we can do that in our final bin, we want 100 pounds and we want it to be 8% protein. So we're going to take a higher concentration of protein and a lower and mix it together to get this 8%. So the question is, do I want 50 pounds and 50 pounds to get the 100? Do I want 20 and 70? And that's what we're trying to figure out. So the pounds from this bucket plus the pounds from here are going to pour in and give me 100 pounds. That's why the variables are so important. Pounds plus pounds, X is pounds, Y is pounds, adds up to 100 pounds. All right, now the next one, all the percentages are going to go together. 12% of this weight is protein. So if there were 100 pounds just in A, then 12% of 100 is 12 pounds of protein, and we'd have 88 pounds of anything else that goes in the food. So 12% of the total, let's multiply. 12% of the weight is protein. So 0.12, change your decimals correctly. 0.12x plus 5% of y. Biggest mistakes is people write 0.5, it's 0.05. So 12% of x and 5% of y, of meaning multiply. 5% of this weight is protein. And then that doesn't just equal 8, it equals 8% of the overall weight. So those are the mistakes I get. If people are doing pretty well but they have some mistakes, one is they mess up the decimal and they write 0.5. When I'm transitioning from percent to a decimal, I'm dividing by 100, and that moves it 2 places to the left. And then the other mistake is people just write 0.08. But I need you to balance this. It's 12% of the weight, 5% of the weight. It's got to be 8% of something. So if you really think about this, 8% of 100 is 8 pounds of protein. And that's what we have here. So this is the protein from here, the protein from here gives us a total protein. So that is my system. And so for the worksheet you're doing today, after this lesson, you're going to do exactly this. You're going to define your variables. If a picture helps you, draw it. But define your variables and set up your system, and that's all you're doing. You're going to stop there because we want to check our systems and make sure they're correct. Now, for today, we're going to keep going. So here is my system, and then I'm going to solve this. And because of these decimals, I'm just going to go ahead and go with the substitution method. So to solve it, I'm going to solve for x, and that equals negative y plus 100. And I'm going to take this, I'm going to stick it right in there. So 0.12 times x plus 0.05y equals 8. I'm going to go ahead and just make that into my 8 there. All right, so that's all we're doing. And now it's just algebra. So this is old news. Take that negative y plus 100 and put it in here, and then go ahead and clean it up. So if you need to use your calculator, go ahead to double check yourself. I think it's great to use your brain, but I don't want you missing things because you misinterpret a number. So I distributed the 0.12, and then I'm going to add like terms. And so one of the mistakes I get is that people take negative 0.12 plus 0.05 and they say it's 0.7. First of all, it's negative, and second, it is 0.07. So be really careful with that. Again, as much as I want you to use your brains, maybe double check yourself on the calculator. Next thing I'm going to do is subtract 12, and I get negative 0.07y is equal to negative 4, and then I'm going to divide by negative 0.07, and I will get a bigger number, and the negatives cancel, which is good. So we get y equals, I'm going to throw this in a calculator, 4 divided by 0.07 is 57.14, and it goes on, and it said to the nearest tenth, so it's going to be 57.1. Now, that's just the y value. I also need x, and then I need labels. The x is not going to be hard to find. X equals negative 57.1 plus 100. All right, well, that's not bad. So x is going to be about 42.9. Let me double check my math here. Yep, 42.9. All right. So typically you would write this as an ordered pair and call it a day, but it's a word problem. So our final answer should be in words, and the final answer would be 42.9 pounds of feed A, or you could say 49.2 pounds at 12% protein, and 57.1 pounds of feed B. So when you're being graded for a worksheet or a test or a quiz, you're getting graded for defining your variables as a number, an amount, a cost, a quantity. It can't just be an object. You can't have feed A. You're getting grades for your system of equations being right, for your work being shown, and then your final answer with proper labels. And there's me 2 labels. We're measuring this in pounds and which it is specifically, so double check that. All right, so let's move on to the next one. A very similar idea, a little bit different. So you're going to see a couple types of problems. So here we go. Example 2. A lab technician is mixing a 10% saline solution, which is just your salt water, with a 4% saline solution. So higher concentration, lower. How much of each solution is needed to make 500 milliliters of a 6% saline solution? All right, so again, we've got this information. It pretty much parallels the problem we just did. And I want to throw out there this idea right here. How much? See it? How much of each solution is needed? That's what my variables are. How much of each solution is needed? So x is going to be the amount or number of milliliters, amount of 10% saline, and that is measured in milliliters. And I know it's measured in milliliters because that's what we want our end result to be. All right. And so it's, well, we already have amount of 10%. And this would be the amount of 4% saline. And that is also measured in milliliters. All right, and we already have the percent there, so I can get rid of that. So we've defined our variables, which are really going to help us in a lot of ways, because now we can understand our equations that we're building, as well as we have the correct labels for our answers. So same idea. If you want to think about this in science, I'll make those little beakers that they have. So here are those little beakers, maybe not the best, and then we're going to put it into one of those big cylindrical beakers. So in this beaker I have 10% saline and 4% saline, and I want to mix it to get a 6%. So if you think about that 6%, it's closer to the 4, so it is weaker than it is strong. So my guess is when I find out how many milliliters, I'm going to have more from the 4% going into here. Okay, with that in mind, we called this X for the number of milliliters. This is Y milliliters, and we know in the end we have 500 milliliters. All right, so looking at that, again, round answers to the nearest milliliter. All right, we want to write our equation. So the first equation I feel like is the one that people have trouble with. It's, to me, the obvious one, but for some people it's not because it's not written out. The liquid in each container is going to add together and give me the total liquid. That's how I need to think about it. The milliliters plus milliliters will give me 500 milliliters. So pick both of these beakers up and dump them in there, and you have that. So that's my first equation, very much like the pounds plus pounds equals pounds. All right, next has to do with percentage, so we can group that. Now, it's 10% of X. So I'm not going to use a percent sign. I'm using my decimal. 10% of X. So if we would put this on a little heat pad and we would quickly evaporate all the liquid, we'd be left with sort of that white residue on the bottom, which is the salt. So 10% of what's in here was salt. And so we want to know how many milliliters of salt there were. So if we would evaporate this, we would have all that salt left over, and we would know what was in there. And it doesn't all evaporate. Some of it goes in the sky. But the idea is, if we were pouring the salt in here, 10% of the milliliters would be salt. So that's what we have. And then 4%, so 0.04 of Y is equal to 6% of the total. And that's really important, guys. It's 10% of the liquid, 4% of this liquid, and 6% of the liquid. You're using that 500 twice in these, just like use the 100. All right, now that I have that, that's my system. So I'm getting points for this, I'm getting points for this, and that's where you're stopping today on the worksheet. But for today in our notes, we're going to go ahead and solve. I'm going to go ahead again and use the substitution method, X equals negative Y plus 500, and then I am going to take this and pop it right into there. So here goes my work. 10% of X plus 4% of Y equals, and then we want to take 6 times 5 is 30, so you just want to double check your decimals there, okay, and so we would have the decimal moving, and so that does give us just 30 milliliters of salt out of these 500 total. And we're going to put this in here as negative Y plus 500. Okay, so you might have solved for Y, and that's fine. We'll get the same end results, just be careful. So go ahead and do your algebra here. So negative 0.10Y plus 20, right, because 5 times 4, and then move the decimal, 20Y is, oh, not 20Y, just 20. Sorry, I moved on. I'm sorry, I just did that wrong. I was taking that times 5, or times 4. Okay, this would just be 50, all right? And then we have our plus 0.04Y equals 30. Okay, so add these together. And again, you want to be really careful here. It's negative 0.10 and 0.04. It's not 0.6, it's negative 0.06Y. I'm going to go ahead and move the 50 at the same time. So I added like terms, I moved the 50, and I got a negative 20, and then I divide by negative 0.06. There'd be no reason to have a negative answer, so watch for that. And I'm going to take 20 divided by 0.06, since the negative signs cancel, and I get 333.3 repeating, but they told me to round to the nearest whole, so 333 is my Y value. Now, if we come back up to find X, X is equal to negative 333 plus 500, and that gives me an x value of 167. So there are my two values. Let's go back over. That's 167, and we're measuring in milliliters of 10% saline. I'll even take up 10%. And it's 333 milliliters of 4% saline. And so my assumption at the beginning was right, that we would have more of the 4% because we didn't have as strong of a liquid. So we were actually making it a little bit weaker of a solution. All right, so let's keep going. I'd like you to take a minute and read example 3 and pause this, because example 3 sets up very much like 1 and 2. It's not that I want you to memorize it, I want you to try to do the layout and think about it. All right, I'm hoping you paused it and worked on it. So we have a cleaning solution. It's 20% acid. It's being mixed with a 5% acid. How much, here it is, how much of each solution to the nearest milliliter is needed to make 150 milliliters of 15% acid solution? So there it is. So how much of each? So X is going to be the amount of 20%. And this is again being measured in milliliters, so always check that. And this is the amount of 5%. So you always want to double check your numbers. We don't have different names for this because it's just the same acid solution, but one stronger and one weaker. And if I want it to be 15% acid, I'm probably going to have more of the 20%, and we're using this 5% to dilute it, to make it a little bit weaker. If it's too strong, it will decolor your clothes, it will discolor your clothes, it could eventually burn holes in the material. So if there's too much acid, it will ruin your clothing. If there's not enough, then it would not do anything to get out the stain. So that's what they're doing, is they're mixing it. Okay, so let's go ahead and think about this. I want a total of 150 milliliters. So if drawing a little picture helps you and organizes your thoughts, then go ahead and draw the picture. So if drawing the picture helps you, I'm just drawing those little cylindrical beakers. You can be as fancy as you want, and here's one at the end. And so I want 150 milliliters here, and in here are X milliliters at 20%, the higher concentration, 5% with Y milliliters, and I have the total here, and it's a mix that gives me 15%. So if I add up the two liquids, X plus Y, I get 150. So liquid plus liquid equals total liquid. Then, if I come back and I think about the percent, 20% of all the liquid in here. So if this is the liquid, this bottom 20% before I mix it up, that's that acid. And in here, here's the liquid, 5% is acid. So it's 20% of X, again, of meaning multiply, 5% of Y is equal to 15% of the total. So you have to think about that. It's 20% of the liquid, 5% of the liquid, 15% of the liquid. All right, so there is my system, and let's go ahead and solve. If you're not happy with having this fraction, you could always go through and multiply to get rid of it. So let's do that in this problem. Let's go ahead and multiply to get rid of it. So if I rewrote this, this would be 22.5. And if you're not happy with having a decimal and it really throws you off, let me rewrite this equation. 0.20x plus 0.05y. So if decimals are what's getting you, you're doing everything right and messing up a decimal, we can multiply everything by 100. And the reason I'm picking 100 is because I have this 5/100ths that I need to get rid of. So everything needs multiplied by 100. So if I do that, my first equation, I'm going to solve for x, and that equals negative y plus 150, just a creature of habit. And then this one, I'm going to multiply by 100, and I will get 20x plus 5y equals 2,250. When I multiply by 100, I shift the decimal 2 places. And so that's how I come up with that. So if you wanted to, you could just take this negative y plus 150 and pop it right into here for x and deal with the decimal. If the decimals are what bothers you, then you can do it this way. All right, so we cleaned it up, and you would have it at 20 times x plus 5y equals 2,250. Plug this in, and that'd be negative 20y plus, it should be 30,000, but I want to double check myself. Yep, sorry, 3,000. I didn't mean 30,000. 3,000 plus 5y equals 2,250. All right, so let's clean it up. I have a negative 15y. I'm going to subtract this 3,000 as I clean it up. Again, if you're not comfortable with that, that's fine. You can do it in 2 steps. And that gives me 750. If we didn't clear the decimal, we'd have these same values, but they'd be in decimal form and smaller. And so we're going to divide by, I should have a negative sign here. Divide by negative 15, that's how I knew I was wrong. And I get y equals 50. All right, so that's y. Let's go back and find x. Negative 50 plus 150. And even though I can do this in my head, I'm showing it, because if this is wrong, my x value would be wrong, but at least I'm showing how I got it. So there are the 2 values. Let's write what they mean and finish this problem. And so it would be that we have 100 milliliters at 20% acid solution, and we have 50 milliliters at 5% acid. And that's it. That's my answer. All right. Now, take a minute and read through example 4, a different setup. Think about a receipt, and we'll work on that. So pause here. I want you to read through, determine what you think the variable should be written as, and what your setup should be. Let's see how your setup is. So it doesn't matter that it was a 12-hour trip from Ohio to the Outer Banks. Doesn't matter that it was the Smith family, but it's all there. So they stopped 2 different times, and they ordered 2 different groups of things. So 3 large drinks and 4 subs, and the total was $22.25. And then they stopped again, and this time they ordered 2 large drinks and 3 subs. Okay, and the total was $16.25. So how much did each large drink cost? Right there. How much did each large drink cost, and how much did each sub cost? Those are my variables. And then there's a note that the cost of each sub and drink were the same at both locations. So it'd have to be the same. So right here, how much did each large drink cost? That's X. Cost, not number of. We know that they ordered 3 drinks and 2 drinks, and they're all large. But it's the cost of the large drink. That's what X is, cost of large drink, and yes, we are going to measure that in dollars. And then Y is the cost. How much did each sub cost? Cost of sub. So I think that sometimes we get carried away that we just write number of or amounts of, but in this one, it's the cost. All right, so we're going to write our 2 equations. I said to think about this as a receipt. The cost of each drink, we don't know. But if I buy 3 of them, it'd be the quantity times the cost. And we've had some visits for this idea. We talked about word problems earlier. So it's 3 is the quantity times the cost of each drink. So 3x would be all the money spent on drinks. And then they bought 4 subs at y dollars each. So if you think about if a drink was $1 each, that'd be $3 in drinks. And if a sub was $3 each, that'd be $12 in subs, and we get our total. Now, our total is $22.25. So those weren't the right prices. But it's money on drinks, money on subs, total money. And then they stopped again. So picture this receipt would be 2 times number of drinks plus 3 times the quantity of sandwiches, and the total bill is $16.25. And so there is my system. And it said solve either using substitution or elimination method. So I am choosing to do the elimination method because we have done 3 substitution problems. So here we go. I would like to eliminate the x's. And I chose x because I only had to build it to 6. If I chose y, I'd have to build it to 12. So I'm going to multiply everything in the first equation by 2. And I put it on the other side so I don't forget. That's the biggest mistake right there, okay? And again, this is old news. We've already done this, and that was supposed to be a 2. We've already done this. So this should be a review. And since this is going to be a positive 6, I'm going to make this a negative 6. and I'm going to multiply to get a -6, and that is going to be multiplied by 3. All right, hopefully I have it all out of my system now. So I need a negative number. So let me rewrite this. Hopefully I won't screw this up. It's been rough. Distribute the 2, so I have a positive 6x, a positive 8y, and then double check yourself here. This should be 4450. All right, so always use your brain, but double check yourself on a calculator. Then this is going to be a negative 6x, a negative 9y, and then I might need to use my calculator. I could take it times 15 and then add on $1.25 times 3, but I would double check myself and I get a negative 4875. Okay, so with the elimination method, and I've already built in the negative sign, the x's cancel like we wanted. I have a negative 1y is equal to a negative 4.25. Well, we can't have a negative answer, so it's good that we have this negative sign divide out. So y is 4.25. Okay, I need x. So I've got y. I'm going to go back to the original, and that would be 3x plus 4 times 425, and that equals 2225. All right, so 3x, and then this would be, what, $17? Double check myself. I'm sure it is. 4 times 425. Yep, 4 times 4, and then another $1, and that equals 2225. And then let's move that 17 over. Now, when I have this 17 here, do you see it? 3 times the cost of a drink, and it's 4 subs at $4.25 each. So they spent $17 on this bill for subs. So if I take the $17 off, if you think about what these numbers mean, if I take $22.50 and I take away, $22.25, and I take away 17, that means the 3 drinks cost a total of $5.25. And then I'm going to divide both sides by 3, and I get x equals, and it should be $1.75. All right, so there are my answers. Let's go ahead and write these out. It would be $1.75 per large drink, and it would be $4.25 per sub. And that is my final answer. And again, are you noticing the 2 labels? It's measured in dollars and what is the item. Measured in dollars and what is the items. So I know this is a longer lesson. Stick with me. We have 2 more problems. I would normally probably split this up, and we wouldn't solve all of them. We would just set them up. But since I'm doing this as a recording, I want to make sure it's all here in one place. So reading this, example 5 is a little bit different. We have Kelly and Brian, and the sum, the answer to the addition of their ages, is 29 years old, or 29 years. And then it says Kelly's age exceeds Brian's by 5 years. And here it is, guys. How old is each person? So x would be one of the ages. And then maybe you don't use x and y. Maybe you use k and b. No matter how you do it, x is Kelly's age, or k is Kelly's age, and that is measured in years. And y is Brian's age, and that is also measured in years. All right. Again, maybe use K and Y or K and B to help you. So here's the deal. The age of Kelly, years, plus the age of Brian in years is equal to 29 years. That's the same idea. Total age, overall age together. And then we have another equation. Kelly's age exceeds Brian's by 5 years. Oh, I just used K and B instead of X and Y. Let's make this K and B. K and B. There you go. So Kelly's age exceeds Brian's. That means that Kelly is older, right? And a lot of people want to do Kelly's age plus 5, and it's not. Kelly's age is equal to Brian's age plus 5. Now, another way that you could have written that, if you were thinking about it differently, is you could have written that Brian is equal to Kelly minus 5. Right? If we have Kelly's age, we take away 5, we get Brian. So it doesn't matter how you write it. I saw it as Kelly's age is. All right, Kelly's age is equal to, and it's going over Brian's by 5 years. So there it is. I'm just going to use substitution here because it's right there. All right, and so that'd be K replaced, plus b equals 29, and I'd put in my b plus 5, and so nothing to distribute. I have 2b plus 5 equals 29, and then 2b equals 24, so b equals 12. Okay, so if b is 12, then k is 12 plus 5, so k is 17. So there we go. Kelly's age is 17 years old, and Brian's age is 12 years old. Or I guess you could have said Kelly is 17 years old, Brian is 12 years old. Fabulous. All right, now all of these you can go back in and check, but you can only check them if your original equations are right. But your answer should work in both equations. All right, last one. Here we go. A little bit different. So here's when I would like you to just pause the video, take a minute, and define your variables and see how you would set it up. All right, so let's see if we agree here. So we have an office. They're printing 1,200 copies of a document using 2 different printers. So 1,200 is the total we need. During the process, printer A gets jammed. Okay, so that means it's probably going to have less. And it prints only half the copies as printer B. Write and solve a system of equations to determine, here it is, the number of copies each printer will produce. So X is going to be the number or amount, so I'm just going to use this. It's not a hashtag, it's a number sign, pound. Number of copies from printer A. And this is going to be number of copies from printer B. There we go. Write the equations. Well, don't lose the obvious one. It's been the same thing in each problem. Copies from A plus copies from B is 1,200 total copies. So to me, that's the obvious one, but it's not obvious to everyone. And the reason it's not obvious to everyone, they don't come out and say it. They just say you have a total of 1,200. So if you think about putting these together, there's your total. So it's an understood equation, but you have to start seeing it. Now the other one comes in sentence form. Printer A prints only half as many as printer B. Okay, so we have to think about this for a minute. Printer A, X, the copies on printer A is equal to half of printer B. Just like that, all right? Printer A puts out or gives or equals or yields half of the other printer. So a lot of us want to take half of printer A, but this has half of Y. So this is going to give us less for X value there. There's my system. And again, I'm going to use substitution here because X is 1/2 Y plus Y equals 1,200. You can do this in decimal form or in fraction form. I'm going to make this as 3/2 Y equals 1,200. You don't have to do that. Maybe you see it as 1.5, but 1/2 and 1 is 1.5, right? And 1.5 is the same as 3/2. So I'm choosing this because the next thing I would do is divide by 3/2. I don't like to divide by fractions. I'm going to multiply by the reciprocal, if I could actually write that. So multiply by the reciprocal. There we go. Multiply by the reciprocal. And, you know, the reason I'm doing that is because I can cross cancel the 3 and the 12. So these cancel. And you could just put it in your calculator too. And the 3 and the 1,200 reduce, and that would give you 400 times 2, so you should get 800. Again, if you're not comfortable with that, you could take your 1,200 times 2/3 in the calculator and get 800. But I was just reducing, and that's a 4, keep my zeros, and then 400 times 2 is 800. Okay, so if printer B makes 800, then printer A is half of 800. And so X is 400. So let's finish our problem by giving our labels. So 400 copies from printer A, or you could just say printer A 400 copies, and then 800 copies from printer B. Now, I know that some of you can figure out some of these problems in your head and you just play with the numbers. This is one that you probably could have played with the numbers and done in your head. You won't get full credit. So you're not just getting graded on your answers. You're getting graded for your variables with a number, a cost, a quantity. You're getting a grade for your system of equations, and then showing that work, and then final answer. So if you want full credit, you need to do all 4 parts, 1, 2, 3, and 4. But something is better than nothing, right? Even if you can just get it set up, or you get an answer, you'll get something, but you won't get full credit. Okay, so keep working on these, and you have a worksheet coming up. And again, in the worksheet, you're only doing the first part for today. You're setting up your variables, setting up your system, and you're going to pause so we can check it.